right, cool. Let's get started. So starting from this hello world as always, but maybe more coming from the streaming side. But this is not really a new thing, right? Everyone kind of embrace this real time today. Like you order, you want to come and pick up you on the Uber side. You order kind of a dish of pizza. You want everything can give you updates in the real time. That's Obvious. And besides that, all the instant message, all the gaming, video, everything is real time. I mean, if this is not real time, you think this is something is broken, right? So that's a very different expectation than what we have maybe 5 years ago, 10 years ago. And that is more from the marketing research institution side, but we don't have to read into the detail, but the idea that is the potential of this real-time data is huge, right? For example, in this first number, about 30% of the new data will be real-time in next few years. And there's only 1% of the data is analyzed, and the rest is just hidden or unused in random file system, in Kafka, in some other system. So if you can have the right tool, the right process, and also making sure you have the right use case and scenario to make a good use of the real-time data, then you have much kind of more advantage to make your customer happy, to tracing with your competitors. And also go back to the more like use case or the reason why this is such a great time for us to work on the real time. Let me just compare what's in the past and what's happening right now. So for the customer demand or expectation side, yeah, I mean, for example, imagine, I'm not sure, I'm coming from China, so it's kind of different story, but in China, everything goes crazy. You order anything like before 11 a.m., you get a chance to get this shipped on the same day. And the people get a much higher expectation, but 5 or 10 years ago, it's common that it's order this week, you get next week, I guess maybe same. You are the local for Vancouver, so maybe is that kind of expectation 5 or 10 years ago?
That you order today and arrive next week?
Yeah.
I think that's the expectation mostly today as well. Right? Like today, if you get it the same day, that's very rare. Okay. Possible, but rare.
Yeah. Yeah, again, the people want to get things faster and but
it definitely is getting faster.
Yeah,
right?
yeah.
You can tell.
Yeah, exactly. And similarly, that is in the past, I guess when I visited the US 10 years ago, maybe I have to make a phone call to reserve, hey, can you send me to the airport tomorrow morning? But now you just pick up your phone and in a few minutes, you can get an Uber to keep up with you. And similarly, that is, you use a certain service and the bill can come quite late. I think, I'm not sure how many of you using EVO. I think when I first arrived Canada or Vancouver, 2000 maybe 17 or 18, when I write a EVO, I cannot see the bill immediately. I have to wait for the next day. They may be doing kind of like Hadoop or MapReduce stuff in the midnight to get generated bill. But today, or recently, that is once I finish this deal, maybe in the next minute I can see how much I spent. Then it's very different experience. People, once the experience or the expectation getting higher, it's very difficult to get low. So the demand is high. In the past, we spent a lot of time on the email, on the Word document. Today, I forgot what's my last time writing a formal email. Everything is on the Slack, and we're using Google Doc a lot. So this cadence is different. And also in the past, people talking about ERP. Today, there's a lot of Web3, IoT, EV cars. So those generate a huge amount of real-time data, and the people want to understand what's going on, what kind of action they should take. And also from the technology side, things make this is much more achievable compared to maybe 5 years ago, 3 years ago even. Like even some of the traditional company today with some legacy stack, they still expect this T+1. That is, if I can run a report to understand what's going on, what was going on yesterday is good enough. For some of the decision making, it's their expectation. But with the new tool, we are having this buzzword like a modern data stack or modern streaming data stack. So people really embracing new tools to kind of doing, for example, A/B testing and doing more documentation, even doing data quality or unit tests for the data itself. And they want to get the data streamlined and have everything can work nicely, and you can get the result in the next few minutes, even next few seconds. So this is quite different than what we have in the past, this T+1 report. Yeah.
Sorry, probably for a wider audience, right? Like I think I understand, like, let's say, hey, now we can do transactions real time versus banks, which used to do ETL at the end of the day for transfer something like that. But does that, like, is it just streaming general concept like which you're talking, or is it like, can't it be just microservices? Can't it be just a plain database? Like before streaming, like, would you say, hey, that's different, or streaming is just general event-driven concept if you're saying?
Yeah. If I understand correctly, it is not really big. Thank you, streaming technology. This might happen. This is a collective technology, right? All the microservices, Kubernetes, all the better database, everything together make this possible and raise the bar for customer having a high expectation to get real-time insight. But it also, this is more like fact, right? So combining this factor together, people wondering why you cannot give me the report earlier, why I have to wait for so long. So the reason why we think this is the right time to work on streaming or work more on the streaming is mainly this two sides. One is the expectation is getting much higher, no matter as an end user or at the enterprise level. And also technology-wise, with this new technology, for example, in the past, we have a lot of like Hadoop or S3 or database-driven data source. And today, like over 70 or 90% of the company are using Kafka. So for example, myself, I think I heard of Kafka. I'm not sure about that, maybe 10 years ago or 12 years ago, if that exists. So at that time, it's still very sexy and modern new technology. But today, it's just the de facto standard. Everyone uses it. Yeah.
I think a little bit of like, if we have kind of operational world and then the analytic world, where in the operation world, you know, say going back to like mainframe, 1980, 1990, something like that. And even sometimes still today, you know, you have something like a grocery store that has orders. It's only writing those orders back into the main system and maybe changing inventory levels at headquarters or things like that at the end of the night. It's not, as transactions are happening throughout the day, it's not actively writing back to it like OLTP database, right? But in the last 10 years, that's changed, where now with, I don't know, Square, say, when you have a Square point of sale, it's online. When you check out, it is actively charging the card actively, it is actively writing to the database. Whereas from the analytic world, I feel like that transition still hasn't fully happened, where we're still in the batch version of it, where, you know, if you think about, Evo, imagine the way that they're doing their billing is with a data system, you know, a Spark job or MapReduce job, like you mentioned. Well, they're still doing it overnight. The idea of doing analytics in a transactional, like with transactional latency, effectively immediately, right? That's not the reality today. That like very, very few systems is more so becoming the reality. Like only those at the leading edge. Anyway, so I just your comment kind of.
No, I think it's more of like I want everyone to be on same page, right? Like it's not just Kafka streams. It's more about event-driven systems. It's more about like ETLs. It's more about how old. As you were saying, it's more about the domain itself, right? In that sense, like you should pitch in. Like I think we should talk more about like. I'll put it this way, right? Like every one of us sort of build system in a different way. And then it's not like, hey, this is the only way to do it. And Kafka could be leveraged in different ways. Same way people say that like monolith works better, with microservices work better. So in that sense, I think like we should share. So that's why I think like we should all jump in and ask so that like we are all on the same page.
Yeah, this is more like the rising of streaming processing. It's not as mature as those OLTP or those standard way. It's getting better, more tools available for you, but there's a lot of different options, pros and cons. That's also part of the reason why we think this is an interesting moment to work on this interesting domain. Right? Yeah, and also like in the past, there's a like Flink, Spark, or even earlier Storm. There's a different ways to doing this data processing in the real time. And the idea of streaming database or streaming, yeah, streaming warehouse is
IoT.
It's nice, yeah.
Sure,
Sure, go ahead, yeah.
they're not real time enough to wait.
Thanks was more like for event driven like things. And what is like the maybe like the advantage or compare for example to a tool like Apache Beam or
Yeah, so maybe Gang can talk about in a much deeper place, but for example, Apache Beam, the idea is more about like abstraction. It's coming from Google. They want stuff like just like Java written once, run anywhere. If it would be nice if you can using the Beam SDK to capture what's your logic, then you can choose whatever actual implementation, either Flink or Spark. But again, they work very hard on that. But from my observation, Beam is not so popular because because it's more like abstraction layer, you might lose the chance to get the, the latest feature from each individual one, and there are certain costs for it to translate. So that's the reason why, for example, Apache Flink is very popular. They evolve very fast, and you might kind of locking on that one, but it might be fine for most of us.
Yeah, I think the problem. I think the problem is that actually Flink is very popular. So Beam provide like Joe mentioned the abstraction layer can change streaming engine can change from Flink to something else. But actually there's no something else. You don't use other streaming processing exactly. Right. So that means why I use Apache Beam, I just use Flink. Right.
I Shopify, when we were moving into stateful streaming, we started with Beam because we didn't have the size of a team in order to deploy our own Flink cluster. And so we thought that Google Cloud Dataflow, which is a serverless way of basically running Beam jobs, was approachable. And we worked on that project for over a year probably. And it ended up working really closely with Google. You know, one of the benefits of being Shopify scale, we had the privilege of doing that and working with the Beam team really closely. And we found that as well that it's the fact that it was a black box, or that it was, I don't know, hidden complexity or whatever, was serverless, ended up being a net negative rather than a net positive, because we all too often we're trying to debug things. We're required to debug things, but we couldn't because we didn't understand how the underlying system worked. So like, you know, what, anyway, so yeah, we ended up switching to Flink because we had a lot more control, basically. There were certain features of Beam that were, or of Google Cloud Dataflow, and using Beam on Google Cloud Dataflow was cool. But yeah, the end-to-end experience of using that product from Google wasn't adequate. And they didn't give us the confidence that we needed in order to commit to that. So we swapped to the open source project and just spun up a team, you know, to manage the cluster and everything.
Yeah, I think that maybe the root cause is you use managing the service, right? The managed service, when it works. When it does not work, the only thing you can do is that you file a support ticket and hope they can solve the problem as soon as possible. Right?
Yeah, I think though that, like,
Of course, I think that secretary itself maybe has some.
had a lot more success with other managed services than it did with Google Cloud Data. So like Shopify's experience with Bigtable, for instance, which is also managed, was fantastic. You know, in the matter of 5 years, Shopify was running many runs, many petabyte size Bigtable instances, spending millions and millions of dollars a year. And there's very few support tickets that go back and forth. It just works. It's simple. It's, you don't ever, or at least for us, once we figured it out, it was fine. Whereas with Dataflow, the model is the computation model, maybe as a developer, but there's so many other considerations that we have to email support way too often, right? Another example that worked well was like serverless Spark. I forget what that's called in Google, whereas the Flink one or the data flow didn't. So I don't mean to derail, but hopefully that helps answer like or give a little bit of perspective on these as well. Happy to talk a little more after.
All right, cool. Yeah, that's good. All the questions and the great insights. Yeah, so I mean, this slide, you can say this is for more like newcomer or beginner, but also that's also very important questions. Why we have to work on this in this way, right? Why you need a streaming database, not doing everything by yourself. The question is actually very similar to why we need a database at the first place, right? So yeah, we are not old enough to witness this part, but at the very beginning, there's no such thing about database. Everyone just handle the file by themselves, and it works okay, right? Works just fine. But later on, you realize, oh, I cannot process big enough files. There's so many concurrencies stuff. I need to handle updates. Then someone come to this idea of like database, so that you don't have to do everything by yourself. Otherwise, you can easily have some auto memory or have too many kind of reinvent the wheel over again. This somehow similar to what we are doing right now. That is those stuff like Kafka, this Flink, they provide a lot of low-level stuff. It might be okay. You don't use database concept. You don't use SQL. You have the chance to get it right, but the cost will be high. You have to write a lot of code, just like doing file system level stuff without using database. And also the other reason is far. That is, if you have limited resource, then it's unlikely you can make this optimized enough to leverage both the most recent OS features or network features. So having a database in general, it will be much easier, much safer, and much faster. And also the reason why we are talking about SQL database for streaming, not just database, because if we talk about database itself, there are so many different ways. I guess there are maybe hundreds or even thousands of different kind of database, not mentioning the actual brand. So all those KV or documentation or different favors. But SQL is still very expressive, and it's good abstraction about what you want to do instead of how you want to do it. And even there's some debate whether SQL is a real standard, because a different database vendor, even the same vendor in different versions, they may implement it in very different ways. Even the major version is the same, but sometimes you hit some issues. But again, compared to other stuff, no matter it's Python library or other framework, SQL is still considered to be a good enough abstraction layer, easy to learn, easy to express. So for example, here I list some of the like code-based database access. Maybe the first one is BerkeleyDB. It's very good, right? So people are still using BerkeleyDB, but it's very low level. And I think the other one is Aerospike, which is very high performance and high throughput database. It's more NoSQL stuff. And on the right is the DynamoDB. It is with a very good reputation, but kind of not so easy to use because you have to use their own private API. So the last part is having a SQL-based streaming database. It makes things so easy to use. Just like iPad, I'm always surprised that those young kids, even like 2 years old, they can just naturally swap, watch movie without any training or reading documents. It's very high bar to be such a great, easy to use product. And using SQL database can somehow make this training process or this onboarding process much shorter because they are already familiar with other kind of SQL database, but in the context of streaming. So in short, because today we are talking about running SQL on Kafka, similar to this idea is using a streaming database. And as I mentioned earlier, that is the key point is really having a very reliable system do this for you. You don't have to reinvent the wheel. And compared to your own solution, it will be much faster. And using SQL, you can leverage your expertise, or you can easily hire more engineers or more analysts in the market to do this streaming processing for you. You don't have to find a very expensive engineer to do that. And the running SQL on Kafka is, or the streaming database concept is almost equal to this one, except some extra stuff. So I will go over very quickly about what's the kind of key concept of the streaming database. So one is that is you can run as SQL for sure, but traditional SQL is you run the SQL to the server do all the crazy scanning and the computation and give you the result, and that's it. But if your data is in Kafka, you always expect new data coming to Kafka. Then how to get the result for the new data? Do you have to using the traditional SQL to run this again? And what's the right frequency? Do you want to run this every 5 minutes, every 5 seconds? So this is fundamentally will be different. So there can be some kind of wasted workload or some kind of other issues if you keep running the same SQL over again. For example, you might send in too many workload to the server have to keep rescanning certain stuff. So in the new world, if you want to running SQL on Kafka, you probably want this unbounded query. You always want the system can give you the latest result without you to ask over again, what's the new result? Ideally, the system can push data to you. So this is more like bounded vs unbounded. Then if you want to get the new result, then you probably want to get a certain kind of aggregation, right? So what's the average, what's the min max, what's the P99? And then for every single aggregation, you need a more like a boundary or defining what's the logic to give you the results in a certain interval or based on the number of events. So that's the idea about the time window, either a fixed window or a size variable window, or it's based on the user transactions. There are certain, it's not really a new term, but there's a lot of discussion about what's the essential time windows or how you even can customize your window based on your own business logic. So this is different than the traditional SQL. Even in the traditional SQL, there's the idea about window, right? So it's more about provisioning, doing top K ranking stuff, but the time window in streaming database is different, and it's also very important because you want to get to the aggregation in the right way. And the other stuff, like if you run a SQL and the SQL is always running, then anything can go wrong will go wrong. So how to handle that is either client side disconnect or server side reboot or some bug. Then you have to making sure there's a certain mechanism to making sure your workload can be resumed when something goes wrong, or if you need more than one worker to work on the same query, and how they can share the state. So that's the idea about the checkpoint. And also, not all the data will come in time, right? With all kinds of reasons, for example, the networking issues, or maybe the device have the wrong clock. All kinds of different factors can give you the result that certain data cannot arrive on time. It's not always the data you expect, which is 1 or 2 seconds ago, maybe it will be 5 minutes late. Then back to our aggregation logic, do you have to keep waiting for all the data, or you have to make a certain kind of a policy, certain late event will be either dropped or will be backfilled? So that's the idea about watermark, which is a fancy term, but the essential is give you the kind of a thresholding stuff, how long will wait for such a late event. And the Materialize, as I mentioned, it has become one of the popular mechanism in different systems. I think more and more, even I think AWS, they have a more materialized view in the Redshift in the recent event, I think. So yeah, so it's become a very popular way to define how you can run a SQL in the background continuously, then you can get to the latest result without waiting. So that's also a cool idea. Even some company name themselves as Materialize, and they are also one of the key players in this domain. Other stuff like if you want to run SQL on Kafka, then do you need to put all the data in the Kafka? Like, do you want to put the recent like 1 month or 1 year data in Kafka, and how expensive it will be? Then there's other messaging bus, or for example, message broker such as Pulsar or even Kafka or Panda. they are all working on this domain to see whether we can have tiered storage, say the recent data in the regular memory / file system, then some older data can be archived to cheaper storage such as S3. So because you want to access a lot of real-time data, or you wanted to compare the real-time data with your historical data, then we cannot assume all the data is always in Kafka. So that's the reason why many of us work on this tiered storage. And lastly, that is not everything is in the Kafka already. You still have data in file system, in database, or in different subsystems like HubSpot or Salesforce. Then how you can making sure all the data will be consolidated in a message bus such as Kafka, then you can run SQL. You don't want to run SQL directly on HubSpot or Salesforce. So you need a certain connector or source connector to move data into Kafka or other message bus. And also, after you run the SQL or after you run the streaming analysis, you probably want to inform other systems or downstream systems to take actions or at least visualize it, right? So this needs a certain kind of sync connectors. So the list can be go on and on. So the basic idea is simple. That is, with more data in Kafka, it will be nice if we can run SQL on Kafka. But it sounds simple, but there's also a lot of other factors you have to consider. So this is the hard part. And also, let me quickly go over the different time window. For example, this one is called time window. It's just every single purple dot represents one data, and on the y-axis, for example, there are 3 different devices, and anytime they can send some new data. But the idea of time window is give you this fixed window. Say I want to aggregate every 1 minute. That in that 1 minute, I can do kind of group by. I can do all the mean, average, or aggregation to figure out what's the value. So I can reduce the amount of raw data and have a much structured with a lower volume. So that's the idea about time window. And the hopping window is similar as this fixed window, but there's certain overlap. The reason is that if you define the time window as say for example, every 1 minute, then you only get result every 1 minute. Sometimes, in some cases, this can be too late. For example, if you are monitoring your server load, or if you are monitoring your device temperature, if you wait for the next window, maybe the device is already too hot. So what you want to do that is, I want to see what's the temperature or the min max temperature for the recent, for example, 5 seconds or 20 seconds, and then this window can keep moving. So this can give you much more kind of in-time notification with the fixed window. And there's other kind of fixed, for example, other changes such as the session window is, the size of the window is different, depends on whether you have idle, whether you have a lot of event in the same time. If the events don't come, if considered as idle, then you can close the window. So this can be very useful if you want to understand, for example, Netflix. You want to understand like how your user watching your video, then you don't want to count those time who are idle. So there's some use case for the session window, and the idea about watermark is really for example, this one you have data coming, and suddenly there's a new data, then you will set this watermark as this blue line. Then in the future, if you get 2 events which is below this watermark, you most likely will not include them in your streaming processing. You still have the chance to put them in other storage. Then you can do some kind of backfill or do some kind of batch processing, but you probably don't want to wait an event which is too long. Then maybe the last one just on the watermark, then you can have the chance to include them. So that's more like the 101 session about why we think this is the either right time or a very critical moment for us to work on streaming database or run SQL on Kafka. Definitely it's not that mature as other domain, but the trend is there, and there's more and more players and more and more either customers or developers want to get real-time data in. Then maybe I will turn to Gang to share more about what kind of option you have and what's their strengths, what's their challenge, and also from our own perspective, what's the future for this domain? Yeah, Gang, please.
Yeah, people should question whether I think we share about a lot. Just sort of questions. Yeah.
Sure. We can hold here, and any questions so far for the what Joe has mentioned. Yeah.
Either you got everything or you didn't get everything.
Yeah, I think when I read something about this, I think the most difficult challenge I can try to solve or try to understand is that the late data, right?
Yeah, you mean the late event?
It's late, right?
Yeah,
You
yeah.
have to receive it.
Right. I can talk a little bit about it, right? So first, why there's a late data, right? So there are a couple of reasons why data is late. So first is the network transportation, right? Because your data is coming from different places.
Okay.
And the network is different, right? And then some might be network is slow, right? The other data is coming, but some data is, that means if someone is coming late, so that means, so if you want to order the data, right? You want the data, you want to order all the data coming from different place, but one of the network is very slow. Even in some cases that the users shut down their devices, like mobile, right? And then they turn on their devices and they will resume sending data. So that data happened like 1 day before, and you get the data very, very late. And then you get a disorder. The even order is totally unordered, right? And how can you handle those data, right?
Video case, for example, I guess every single video car has a certain device to inform their location, their speed. Then imagine you are driving a video at a multiple tunnel. It still tries to send data out, but the tunnel is too long, there's no out. And when you exit the tunnel, this connection may happen, then this event around the center. Imagine on the server side, you want to do stuff like, hey, how many cars starting right now? You probably will miss the previous event, but when this late event arrives, you probably will just throw this away because it's already late.
Yeah, so if you accept the so-called late data, then the longer you're willing to wait, let's say worst case, you wait 1 day. I know maybe some data will come to like 1 day late.
Yeah.
Then we are not doing real time.
Yeah, it's not real time. So that's why we have to throw it. User has to have the watermark, right? If all your data coming from one place, it's much simpler because the watermark means if I got the data, say it's from 10 o'clock, right? And I will believe that all the data come before 10 o'clock is not possible. Or when it comes, I just throw it. Because in most of the cases, that means the time is going forward. That's why the watermark works, right? But
door is closed.
yeah, door is closed. All the late data, but that also related to your query, because only if your query has a bound, then the late event happen. Because if you're unbounded, right, you just can't say I want to do analysis, say how many data, the count of all the data, right? Then you don't care about late data because every data coming you just count, right? Okay. So then that's fine. But in case you have the window aggregation, right? I want to aggregate data in past 1 minute, right? So that means your analytic has a clear time boundary. In that case, I will throw the late data because I won't wait forever, right? For the late data, right? So that's related to your query type. Yeah.
More of a comment, I guess, but like one thing that really helped me when thinking about these things is that, like in an ideal world, the database could react to, it's just trying to update, you give it some report and it's trying to give you the result of that that SQL query, whenever something changes on the input, it gives you, it mutates whatever row is on the output. And a lot of these constructs, like giving parameters around how much layer routing data you might have, is often to help the streaming system be efficient in its memory footprint, or its storage footprint. So it's kind of like giving, at least kind of the way I think about it, is often putting some constraints around your ID. Like ideally, you just be able to say, here's my SQL query, figure it out. If it's late, who cares? You figure it out, right? But often giving these hints can help the database be way more efficient, be way more efficient with its memory. Kind of like giving garbage collection hints, that sort of.
Like the gate, right? Like if the gate closed, I'm safely can drop those data.
Exactly.
Yeah. The memory, because I said it's passed and I'm not going to use that data. Even if I say those data gone, right?
Yeah.
Okay.
I think when you think about giving a SQL query, if you want it streaming, well, why? I just wanted to write my SQL query, and all of these other ideas of windows and watermarks and everything are they're really complicated, and they take months and months to learn.
Yeah.
And it's a double-edged sword. But usually, I think in my experience, it's there to kind of help the system be more efficient in its. So you're not asking it to do some unbounded computation with an unbounded memory footprint, basically.
No, I think in one perspective, it makes sense to me, like when you're thinking of reports, even though it doesn't matter when you generate the data, but also I want to know how much revenue is made per day. Yeah. Because it doesn't matter like whether you fall on the next minute or the next day, but you still want the data to be in the report of previous day. Yeah. So in that sense, watermark makes sense to me. But I haven't written a lot of what do you call that, streaming. So it's a question in a way. So when the source generates data late, we can't figure it out, right? Like you gave an example of tunnel, but when the source itself generates the data late, like that's something you can't.
So actually, we do have some customer. This is for our products. The idea of watermark. The basic way is you set watermark 0, meaning that you don't want to wait. If you be nice and you also want okay to have a slow message, say 10 seconds after the watermark. It's more like, hey, I have a bus. The bus will leave at 6 p.m. But I will wait for 10 seconds more. And if someone can get in, I will get in more. But I will not need longer. But the problem of that is it's global watermark. And some of our customers, for example, we have clients working on the fleet management. Then there will be some cases, each car or each car, they have different clock. Meaning that is certain clock is delayed, it's always delayed. Then what we have right now is we have this more like substream or partition-based watermark. So every single primary key we can maintain a watermark. So if this clock, they always using this clock, then it's okay because we constantly have 5-minute delay. Then we don't think this is a real delay. Okay. So we can, in some cases, we can detect such we call time skew or kind of different stuff. But if the source generates a random late event, then that's much we can do.
So even if the data is like late, then it adjusts, and then like you put the data in the right window by using a watermark. Like that's what you use it for. Like I prefer something else.
Yeah, as long as their orders is correct. They are not sending like this event and the back event, that will be very difficult. But if their event is in order, then our watermark is not based on the we call wall clock. It's based on their event time. So we can set say you give me an event, say this is T4. Then next time is T5. Then I set the watermark as T5. No matter is that like 5 minutes ago or 5 seconds ago. As long as you can keep giving me this ordered event, I can set this watermark based on your event, not based on my current watermark. But anyway, as Matt said, this can be very complex. Multiple times to
that's ideal case because late event come from future. And you can never predict the future. So it's something, that's why streaming process is actually approximate. So we just estimate. So it's not accurate. If you want to get accurate data, you have to wait the data coming and do a like batch, right?
Yeah, I think that the source, if the source is bad, you're really hard to deal with, right? They call it garbage in, garbage out, right? Now you say, I'm going to garbage in, and then you don't expect the perfect things out.
Right.
And
Yeah.
in other sense, I don't
Yeah.
know if this applies in batching, right?
Yeah, because I
In
remember,
batching, we never talk about what models.
yeah, because I remember one time the worst is that something earlier. So sometimes the copies that even faster than you. But you think it's like six, they're already like at 610, and they tell you something already happening in the future, and they're like, oh.
So if we don't accept the late data, and it's not cause all the entire data wrong or something, message wrong or something.
So depends on what kind of question you want to ask. If you
Yeah.
ask EVO, what's the current, how many cars on the street? That case, you give an answer which is reflect the current data you see, which is. But
You know, like Uber say, like they write certain like a tool, and but the data come late, and they didn't receive, and which means like we don't charge or
yeah, so that's also we usually combine the streaming processing with other stuff like you run a daily report or do some kind of a backfill to making sure all the late events will be calculated. Maybe the bill will be adjusted. So we will accept the world is not perfect. There might be some late events. To making sure you don't wait too long for your stream processing, we drop it. That doesn't mean it will drop to garbage. It will be somewhere else.
Okay.
And you still have a chance to calculate in your batch processing.
Probably one point a lot, yeah, we should continue after that. It depends on the context, right? Let's say all of you would have noticed in a live tracking app, the driver suddenly moves like 10 points forward, like from one street to other point, if it's lagging, right? So at a live tracking, all you care about is the current location of the driver. It doesn't matter if you lose 10 data on the way. So that's why you see if the internet connection of the driver is bad, the icon just moves fast. Okay. But in context of financial systems, you can't drop data, right? Like it doesn't matter like whether it's 2 seconds, whether it's 10 seconds, but I don't want to miss any data because imagine this data is responsible for paying drivers. Yeah. So you don't want to miss any data. So in that context, you can't drop data. But I think like probably there, it's more about reporting. How you're processing is different. So dropping data is very subjective on that context. If you want a performance system, okay to lose data, then you do it. If not, like it's a critical system, you can't miss a different message. Those things doesn't apply.
Right.
Yeah.
Okay, so yeah, let's continue. So next, I'm going to talk about some of those databases, technologies that we can use to analysis or query data on Kafka, right? We are going to talk about ksqlDB. We are going to talk about Flink and Spark. There's Trino. So probably you know Presto, but basically Trino is the same as Presto. There's like Matt had mentioned, the Materialize DB. And there's another database vendor called Rising Wave. It's actually very similar like Materialize, same technology, same concept. And of course, we are going to talk about Timeplus, which is what we are building. We have a database, stream database core engine as well. So I'm going to talk about these different technologies, do some basic demos, and then we can wrap up to compare what's the difference between these different technologies. Okay, so first thing I'm going to talk about Flink, because Flink is the de facto standard for stream processing, right? So basically you can run FlinkSQL to query data on Kafka. So in that case, the model is something like this. So you have a table. And when you create a table, you set up a connector to the Kafka, right? And that connector is actually a bidirectional. So it means you can query, the table is connected to the Kafka. You can query the data from Kafka when you run select. Also, you can insert data to Kafka by inserting into that table. So it's something like when you have a table in Flink, right? It build a bidirectional connection with the Kafka. Yeah. Next, I'm going to show you some demo. So first, I have set up a Kafka, in my cluster. So I actually have this is a Kafka UI I'm using. So it's a nice UI. So you can see. I'm sorry. Let me check. I think the Kafka might be. I'm not sure if you can see the terminal. Let me check the. Let me check if the Kafka is running.
Yeah, by the way, this is the market-based machine.
Yeah. So you see, I have a 3-node cluster of Kafka running here. Let me check the Kafka UI to make sure it is running. I think I didn't.
This is running in our own EKS.
So this is our Kubernetes cluster. So I run everything.
The UI behind is the Kafka UI. It's open source.
Yeah, it's open. Let me.
We'll talk about how you. Yeah.
Right.
I thought you noticed like yours.
Yeah.
Yeah, our
Yeah. Make. So let me check if the Kafka. You can see this is the topic. So this is our demo Kafka data. So it simulates some. There's a shared car like a EVO, right? We talk about. So each car is actually sending data, right? So let me open the Kafka UI so you can see better. Okay. So I just open the forwarder so I can. You see, this is my cluster. I have a. Sure. You see? So it's a 3-node cluster, right? So the topic I'm going to use is actually this car leave data. So you can see the data is something like this, right? I don't know if we can. Right, it doesn't show everything, but if you go to the if we go to the shell, you can see actually there's a lot of data. It's a JSON data, right? So every car is sending data to the Kafka topic. Okay. So next I'm going to because my Flink cluster is running. It's a simple Flink cluster, so I just run the Flink SQL client. So it will give me a shell, so you can run FlinkSQL. So this is the FlinkSQL. So actually, I have all the. So here is the FlinkSQL I'm going to show. So let's first is I'm going to set up the result model. It's actually not relevant because FlinkSQL has different result mode. So we are going to use this Tableau mode so that all the data just showing in your console instead of a pop up another UI. So the first thing I'm going to do, so like I create a table. I make it bigger. So actually, the first thing I'm going to do is create a table. So this table will, you can see something important is with, there's some options here, right? So it uses a connector. So I connect to Kafka, the topic, and the mode is latest offset, means I get data from the very latest one. Of course, you can get data from the earliest one, means you get more data. But in the streaming processing or real-time world, I only care about the new data, right? So, and this is my Kafka server, and the value is like JSON format, right? So by doing so, we actually create a table in Flink. And I show tables. You get the table has been created. So I can actually select, I run a simple query, say, just show me everything on this table. I don't know if it's still working. It seems a little bit slow. Yeah, it's, yeah, it should be continually give you data. You see, it's a little bit slow because maybe Java in Flink world, it has to create a job, submit the job, so it has some bootstrap time. So it's not that interactive, but once the job is running, it looks fine, right? You get all the data, and of course you can run some complex query. So for example, my next sample is actually run tumble window. So I want to aggregate the data in a 5-second window. So actually in Flink, you have this tumble function. So the interval is 5 seconds. That means I aggregate data every 5 seconds. So let's see what it looks like. So this means I calculate the max speed in a 5-second window. So in every 5 seconds, what is the max speed for the car? So it actually calculates check all the cars, right? I didn't add any other conditions. Of course, I can add more conditions, but just give some example here, right?
Yeah, and sometimes we call this as a downsampling. So you get a lot of random data from Kafka.
Right.
And then you probably want your BI team to visualize it using other stuff, and you want to send this data back to your Postgres or Snowflake.
Right.
And you can use it to reduce the number of raw data and the much structured data.
So yeah, this is giving impression like you can see that every 5 seconds it gives us a result, right? And that like 112 is actually the max speed of all the cars in that 5 second window, right? Of course, I can change the window size to 1 hour or whatever, right? So, but you get the concept that I'm running a downsampling or aggregation in a time window based, style. And also you can get the difference compared to the traditional SQL is that it's an unbounded query, right? The data is pushing data to you. The query is pushing data to you. It never ends unless you cancel it, right? And it continually push your data. So that's why you get a very low latency, right? So actually your question will be, what is the max speed in the last 5 seconds, right? And it always give you the latest result without any, latency. So that's why we call it real time, right? Okay.
By the way, compared to the traditional database, right now there's a lot of so-called database, but they don't really have this streaming mechanism or semantics. What they are really doing is you issue a query, say, where time greater than now minus 5. So what they are doing actually is they receive the query, they do a quick scraping or sorting for current data. Then they figure out this is the amount of data, then do a kind of operation for you. But every time you issue a query, they starting from the whole data set, do a warehouse, then give you the result. But in this kind of streaming SQL or continuous query, the engine is more stable, right? We get the number of data, new data in this window, and we do this incremental update. So we don't have to rescan the update with this much better. So that's kind of the difference between a fast database vs a stream database.
Yeah. Okay. Next, I'm going to show that I need an analytic result into Kafka again, right? I done my job. I do the analysis, and I want to send data to a downstream, processing, which is using Kafka is very convenient as well. So I use the same connector. So I create a sync connector. So I'm creating a temporary table, and that table is connecting to a called FlinkSQL Cardiff data sync topic. And I created this table, and then I run a query to insert my analytic result into that topic. So then here's the, say, insert into this table with the same query I was running, right? So let me run this query. And now you can see actually it submit a job and there's a job ID. Actually, it's a Flink job running under the hood. And this is more like a Materialize view because it's continuous running backend. And if we go to the topic, I think the topic has been created. So let's check if there's such topic. So it's not there yet.
Yeah, I see that as a second one, second bottom.
Second one?
Yeah.
This one? No, it's ksql. I see. It's different one. Yeah, maybe it takes some time. It takes some time.
There.
Yeah, it's coming, right? This is the Flink one. So it actually backend job create as topic and it's insert the analytical result into that table, right? We probably can view this. You mean this one? Yeah. Yeah, you can see the max speed is 0. I think that's probably something wrong. Yeah. I think it's not 0 for sure, but something's wrong with Flink, right? But you know the idea, right? We run something. So this is the first one. I don't have quite a lot of experience using FlinkSQL, but actually, I can share my experience, right? What I got when I running FlinkSQL. It's hard to maintain, hard to set up. Like Matt mentioned, why they're using Beam, it's actually they are looking for some managed services, so they don't have to maintain everything. Because for the open source stack, the problem is if you want to set up your own stack, it usually take you a lot of efforts. Because for Flink, the problem is that you have to find the right version. Right? In the most of case, Flink has a lot of different versions, and every different version works cannot work with the other versions. You have to handle the Java version because you have Java 8, Java 20, or whatever, right? You have to handle the Scala version because different Scala version doesn't work together as well. And also you have to work with the third-party version because in this case you have to include Kafka connector. The Kafka connector has a lot of different versions as well. So if all these different versions doesn't match, any of this doesn't match, the job fails. There's some other issue as well. It's not quite stable. If any of the environment settings or any settings wrong, the Flink terminal doesn't work, the query doesn't work, and it give you some errors that not relevant. You have to figure out what's running. Yeah.
Just very quickly, one of the other experiences that we had at Shopify managing Flink. I don't know if you guys know Yaroslav, who he wanted to be here today, but he's away.
Yeah.
But he spent a lot of time focusing on the state backend.
Yeah.
And having, like, as you loaded more and more data into Flink, how not to overwhelm your Flink cluster. Right. So then there became a lot of like JVM tuning.
Right.
And I forgot, is it RocksDB? I think. And
it's RocksDB.
So like the RocksDB tuning as well. Anyway, it was just like, it was a whole team endeavor in order to manage a Flink cluster. And even still, there was a lot of details that had nothing to do with the business outcome we were focused on.
Right.
I mean, Ghana and I work in very big company, in a very big team on this stream processing. We have a team of maybe 15 work on Kubernetes alone. The other maybe team of 15 or 20 work on Flink alone. So and even today, I think there's a new business model, this managed Flink, like Emerald or other stuff.
Emerald.
It's become a real thing because it is very powerful, but again, it's very costly for you to do it right. So.
Right. Yeah. Okay. That's the first. There's some other things I'm not going to share, but give you some expressions.
Just 2 minutes quickly catching you folks. We talked initially about like how the streaming sort of playing a role in like modern tech systems, like how the real world applications where we are looking at everyday real time rather than like bank systems where you used to see day once in a day, right? And then they showed multiple products in that space. We talked a bit about like key concepts and like the whole streaming, like especially we are talking about streaming. So they shared about like windowing, aggregation, specific concepts. And Flink is one such tool to aggregate and then do this real time. Like it's a tool in streaming, well-known tool. I think he's just talking about more tools in this space. So yeah, like we skipped a lot of concepts. So you can probably ask later. So we are in the part where like how this tools is giving us leverage and then what are we doing with streaming?
Right.
Yeah.
Right. Yeah. So even though Flink has a, it's more like a developer tool. If you have a development team, you probably can handle Flink, right? But if you don't have a dedicated technical team, right? It could be hard for you to run Flink. Yeah, but still, Flink is popular. It's still the best stream processing engine and widely used, right? So if you do have knowledge and you have, I think you have a strong team, you can. Flink is a good choice if you want to search, or query data on Kafka, right? So Flink is the first one we show here. So next one, I'm going to talk about Trino. So probably if you don't know Trino, you probably know Presto, right? They're basically same, but the community was kind of break into two, product. You can, if you are interested to that story, you can search. But basically, Trino is it used to be, I think, developed by Facebook, right? It's a in-memory database engine, right? You can query data anywhere using Presto. It's an open framework. So Trino has a Kafka connector as well. So you can see the architecture or concept is quite similar like a Flink, right? But the only difference is that Flink is a stream processing engine and Trino is actually a batch, right? So when you build this connector with Trino, the idea you can do the similar stuff, but what Trino is doing is actually scan all your data in Kafka and probably put them in the memory and give you analytical result. But it's not in a streaming way. It's more like in a batching way. And another one is actually it needs some manually configuration. When you use Trino, you have to manually configure this connector to the table because it doesn't have like in previous sample you can do everything in SQL, right? But when Trino you actually need to do some configuration like this. I'm going to show the Trino one. So first one, you put some Kafka property in your system to configure the Kafka schema. And then if you want to decode the JSON in the Kafka, you need to create some table configuration. So this one cannot be done in the SQL way. So you have to pre-configure these settings by yourself. So that's not flexible. That's how Trino is working. I've already set all this down. So I will go directly into the Trino SQL part. Right. Let's take a look how Trino works.
So you're showing Trino here as a contrast, like as an example of the batch SQL.
Yeah.
Kafka.
Yeah. If you want, yeah, because today we're going to talk about using SQL to query data on Kafka, right? It doesn't have to be a streaming SQL, right?
Cool.
So okay. So I'm going to log to my Trino shell, Trino command. I'm going to show like schema. I think we have a schema. Schemas. Okay, I have a schema, two schema. One is default because I put the Kafka in default. I like show the tables because, like I mentioned, we already make the configuration. So the car live data and the sync, I already created these two tables. So I don't, because I have to do it in a configuration file. I cannot create this table using like a create SQL command. You have to do it with configurations. So it's
I have a quick question. So
yeah.
If you need to add a table, so meaning you have to kind of restart Kafka.
Yeah, not restart Kafka, restart Trino, not Kafka. The Kafka is running there, right? The same topic we are going to show, but the Trino create a table, connect the data to Kafka, right? So if you want to add a new table, you have to do configuration, restart your Trino. Yeah, so that's why it's not that convenient.
You call this different here you know the managing the storage just take some query and check the actual language for that speaking on it. And try to consolidate all the interface into the two. So yeah, if you want to add a more than that source, so you don't have to restart the
Yeah. So I think let me check our is our broker still working? Yeah. So let's go back to Trino. So let's select. I think the count might be wrong. Why it's return 1? I do some yeah. I do some simple query. Trino. So as I mentioned, Trino is like a batch processing. When I run the same query, I actually search all the data, and you can see we got this data. You can pull down, but it's not streaming way, right? You run a patch, it pull data into memory and give you the result, right? And what I'm going to do next is probably I will run a simple aggregation, because it's a batch. It doesn't relate to it's not a streaming processing, so it doesn't use it doesn't have any window concept, right? Unless you want to downsampling the historical data, but usually there's no such tumble or hopping window provided by the batch database. So I run a simple aggregation here. So it's the same aggregation, but it's actually global, right? I agreed. I found the max speed per car, right? Tell me what's the max speed for each car, including in all the data, right? I'm running something like this, but it could be slow, right? You can see the progress bar is 9% now, because like Matt has mentioned that for the streaming analytic, it's still very early, right? One of the problem is that like if you're using some traditional database like this, you will scan all the data in the Kafka, and usually it's slow, right? Because there's a lot of data, not compared to the OLAP or other analytic database where data is stored in a column database, or you build some index. That means you can scan your data very fast and skip unnecessary data. But with Kafka is a append-only log. You cannot skip. You have to read from the very beginning to the end, right? So in that case, you can see if I do an aggregation, it's very slow because it's try to read data from the very beginning or to now. So it takes some time.
Is this reading directly from Kafka? Like the Trino connector is not to Parquet files, but to the Kafka topic get heard.
Yeah, it's read from the Kafka topic.
Actually, it's not too bad. About every second is like 20 seconds.
There's a lot of data. Yeah, it's not bad, but it's a lot of data.
And there's
Right.
no index, there's no.
Yeah.
It's also about capture, right? Like, I think when you're starting and there's too much data and then you're doing select start,
Right.
then doing last seconds. So that's also why it's slow, or it's just query.
Yeah.
Yeah, you have set some.
Yeah, right. I think I don't know how Trino process last 5 minutes, because Kafka do has an offset, right? You probably can find the offset of last 5 minutes and make the fewer. But the problem Trino has a standard SQL engine, right? Probably they didn't implement the where predicate to filter out data. That's why actually I can show that later because Timeplus can do that very easily because we are building for a streaming engine, right? Okay, and next, similarly, we can insert into the sink and with some aggregation data. Okay, the insert column.
You could actually get what this data is, what this table is about. What this table is in data, like are you on sync or you have questions?
No, so Brian.
Have you could use Kafka?
I'm a beginner.
Okay.
Insert, so there should be a comma.
Sure.
Which one?
Yeah, the first
Feel free to
Yeah.
questions on yeah, two questions.
Okay, yeah, because
That's just like tools and how they work.
Yeah, so this data is basically like they have a line data of car speed coming in. That's one thing. The other table is created as give me a maximum speed of once the cars per loss of 5 minutes. So
Yeah, I think it's the reason the count, the code count somehow that's not used. That maybe it will cut nothing to find it.
yeah, I'm running an insert, but there's a comma missing because that's because of my hyperquery just trim your comma. But it's running now. It's actually insert into this target table with the query result. So let's go to the topic and take a look at this. We should have a trino. Let me take a look.
So I have a question, perhaps a silly question, but like, are these tools like production safe? Right now they're like in beta.
Most of the tool today we discuss is open source, being there for a long time. So many people use production level training, trino. Yeah, I cannot guarantee everything is appropriate, but at a high sometimes you might be concluding that in general they
Yeah. So you can see this insert into the similar like the Flink one, but it's a batch, right? It's still running progressively. So the topic is not here yet. So once it's ready, there should be a topic created similarly, a trino sync, so you get the data there. So now you can see the fundamental difference compared to trino, and okay, I think it's ready, right? So let me take a look. Okay, it's maybe not there. So anyway, so if you run this query, you should get a result. The only difference is that trino is a batch, right? You have a batch job, you run once and get result, and the Flink is a streaming, right? You get the real-time result pushing to you. That's the key difference. So it depends on which scenario you're running, right? If you don't care about the real time, it's not time sensitive, and you want to run a report in a batch, probably you can use trino as well. But if you do care about the latency is important to you, you want to get the result in the first place, you probably run Flink.
I think it's important to call out that like the queries were very different.
Mm-hmm.
And that if you wanted to, you could have had the trino query, you could have implemented something similar in Flink, but not vice versa. The trino thing couldn't be implemented in the Flink couldn't be implemented in trino.
Right. So yeah, the fundamental streaming process is quite different, right?
Yeah.
So curious on one, if we write a custom consumer and transform it and push it, we have a lot of control. What happens if the contract changes? Do you have to go and touch all the existing tables and like how you have to set up the queries and stuff, or
right?
How do you update? Like I'm guessing if you have 10 topics, if you have such transformer, you have 20 tables. It becomes complex, right? If you're touching a contract, what happens in that case? Like usually in this.
So
like adding a new field to the data, or
you mean your schema is
schema change.
Schema change or your query change, right? Yeah. You have to if you're using open source Word, you'll have to do it by yourself. You have to manage by yourself. Yeah.
Okay,
That's
so
it.
so because we need to touch.
Because these two are all. You mean?
Let's say if you add a new colon, say new colon.
Right, I think for Trino case, it's
Yeah.
very complex. For Blink, it could be done, because you run everything in Java code or SQL, right? But for Trino, I think it's kind of complex. You see the configuration, right? You manage the configuration. It's not dynamic. You have to do it manually. It's hard.
Yeah, but again, the schema evolution can be a separate topic.
Yeah,
Or
there's a
we
big
can talk
part.
about it, like, there's like so many different solutions, a lot of pain points. For example, for us, we sometimes do this stuff. We can just change the one column from, for example, int 32 to int 64, it might be okay. But sometimes if you add a new column, remove column, have a very different structure, you might have to have a kind of a different stream or different topics. Like, there's a lot of article regarding what's the best way to define Kafka topic, whether the virtual name should be part of it. And sometimes you even have to use stuff like union. You run a query, run the other query, and make it a CTE that union it. There's a lot of but that's erratic, so we might have to handle it, but it's very big time.
In my experience, you kind of like, if you're gonna change the code, it's easiest just to spin up a whole new version of the topic, backfill it.
Right.
And then once it's caught up, then do an atomic swap, like with some pointer somewhere else,
Yeah.
and then spin down the old one. That like you kind of need to build. You're relying, especially even on these tools, to know how to like do the memory mapping. And anyway, but without getting off topic, like
Yeah.
especially if it's in production, it's like way more easy to just not change anything and just spin up a whole other parallel pipeline.
No, I think I would be lucky in that case to like change the consumer's topic, right? Like in our case, there's thousands of consumers.
Yeah, so then you need to do that, and that's a huge pain.
Yeah, we can't do that. Like we usually don't break compatibility, backward compatibility, but when we add fields, they slowly catch up with they need it. So somebody can be in an old version, but I don't know what happens to the tables after. I was curious, but we don't break contract, but rather the additions is always expected. You can always add a new field, the location, and then price, driver, and whatnot. Right? So yeah, I think it's really, anyways, we can discuss.
Yeah. Right. Yeah, we can talk about that. Next one, I'm going to talk about the ksqlDB, because if you are using Confluent or you use Confluent Cloud, it's a all-in-one solution. You have ksql, you have Kafka Connect, you have schema registry. Anyway, there's a lot of stuff in that bucket, right? And ksqlDB is another one. It's tightly integrated with Kafka. So basically, it can. There's something different because in ksql concept they have table and stream. Right? That's something different. Well, I'm going to explain it a little bit. Stream is similar like the Kafka topic. It's a append only, right? It's event based. You get even 1, even 2, even 3, append only to the stream. A table is something different because when in Kafka ksqlDB, the concept is for the table you have a key, right? For example, you have the key is a car ID. Right? I have the car ID. Say my speed is 100, and the same car ID even come on say 102. That means probably you update the table, right? You get a new version of the car speed based on the same key. So for each key, you only keep a latest version. Right? That's the table compared to the stream. So actually, I think Confluent has a famous slides talk about that. The two sides of the same form, table and stream. That's how the Confluent ksql make the model. So basically, you can create table and stream, and you can that table and stream can connect to the Kafka topic, and you can run query on the table or on the stream. I can do some quick demo on this as well. So let's start the ksql client. So I'm going to show streams. I think there's no streams created or no table as well. Okay, I'm going to create those stuffs using ksql. So the first one, you can create a stream. In this case, you can see it's quite similar like what we were doing in Flink, right? So you create a stream. The only difference is it's a stream, right? And it has all the fields and the topic name, the values. And you can see I didn't specify the brokers, right? Because ksql is tightly integrated with your Kafka. So you cannot read data from any other brokers. You have to read data from the same broker that has been set up to your ksql. Right? So let me create a stream first. So after I create this stream, if I say show streams, you see there's one stream called car live data. And then I can run some very simple query, say what's happening with this car live data. You can see it's much better than Flink. It gives you a result immediately because there's no like Flink job creation, submit job. So it's much better, right? And it looks faster as well. Right. So that's because I think Confluent make a good integration with their own product, right? So okay, and next I'm going to run this window aggregation. You see, the aggregation. The only difference is that for this query, it's similar like the tumble, different grammar, but you can see the idea is the same, right? So I aggregate per car, group by CID per car, the average gas percentage and max speed per, like say, per 6 seconds. That means 1 minute. I can run this. And you probably mentioned that there's an image chain. That means I want to push data to you. So that's quite different grammar, but basically it tells so because it's a 6 second, 1 minute aggregation. So probably we need to wait a little bit. I don't know. Yeah.
You mentioned like it's a broker which is a batch. Isn't it like generic like hey, I just need to get the data from this topic, like, or is it specifically this broker, this partition? Like why?
Sorry,
Earlier you mentioned like we need to run the queries where the ksql is set up. Is it like per broker, but it's just topic level, right? Like I'm just clarifying.
Under the hood, there's a broker, right? So ksql already configured using this broker as the start or something, right? Anyway, so you can see in the Flink case, you can read data from different brokers and set up that. But in the ksql, it's tightly bounded because that means ksql has to read data from this specific broker.
So you can like a cluster level, like if I have 3 brokers.
Right.
One topic is only in this broker, the other topic is in a different broker.
Because it's a cluster, right? You have 3 brokers. You don't care which topic. It doesn't care which which brokers. So there's a cluster. It's a cluster.
I think what he means is there is a like broker like a gateway. So you have to talk that broker for your
you have to talk to
the 1, 2, 3. You cannot talk to 2 or 3. Because if they don't have
it's the broker. I mean the cluster. Your cluster has 1 or 3 brokers. That doesn't matter because this cluster already funded to your ksqlDB because it's part of the cluster already. So if you have another Kafka cluster, you set up an external cluster. This ksql cannot read the data from that. You have to read the data from your same cluster. It's already
cluster makes sense. I was just confused. Like
it's a class.
got it.
It's so I mean So do you know why it's like that? So why is it, for example, yeah, one in Google Cloud, one in Amazon, why?
Yeah, it's the design of the Confluent can give you Confluent take the Kafka as the underhood storage of the stream engine, right? It's tightly binding. So if you want to do if you want to read the data from other cluster, you have to change your ksqlDB setting. Say my ksqlDB read data from Dhaka.
Oh, okay, I see.
So this is but there's something different I want to show you here is actually if I read data if I run this specific query, say I want to get aggregation, but where I want to check this specific car, right? So what's the result? So here you probably can see some difference here. So there's still a 1 minutes aggregation, but you can see actually it give you a result. It's not it doesn't close the window in 1 minute. Instead, it gives you data every time there's an event. So that's a different trigger mechanism. So like in Flink, I actually close the window every, because if it's a 1 minute window, it close the window on the window close on 1 minute. But in the ksql style, it's actually give you aggregation result every time there's an event. So it's event based.
Yeah, but I think in the recent version of ksql, they have this new they call emit final. That is when the window closed, they can emit once. Not this incremental. We are also lucky enough to be in this streaming SQL working group of ISO or whatever. So we are trying to working with companies such as Materialize or SQL. We try to define extra SQL syntax to make this easier for streaming. So we are discussing whether this either emit final is the right way, whether we should hold define query media checkpoints. For example, we are leaning towards using subquery tool. So, but it will take multiple years. I don't think it will be published anytime soon, but there's some discussion on that. And there's so many different ways to doing that. We really need to consolidate and take some lesson learned from each other.
Is that working group? I know there was a paper written a couple of years ago by the guy from Beam, Tyler Akaidu, and the Calcite, somebody from Calcite, I think, and Fabian maybe?
Yeah.
Is that the same group of people?
Yeah, Fabian.
Yeah.
Someone from.
Snowflake.
Yeah.
Okay.
Yeah, we actually meet them in Austin. There's a current meeting, right? The Kafka Summit in Austin. Yeah, we talked to those guys. Yeah.
Cool.
Yeah, so you can see that there's a fundamental difference if you want to per event in. We only want to emit once when the window closes, right? They're quite different. If you use per event emit, actually don't care about late event, because every time the event comes, you just emit a result, right? You don't need to care about the event. But if it's a final, like a window on window close, that means you have to throw away any event that's late. Right? So that's the difference. So the ksql is the one that default give you event based emit, right? So that's one difference I want to show you. So and that next one, I'm going to create this sync, and then I'm going to insert data into it. Yeah, probably I just show the final one, this one. So this grammar it create a table, and then it do some aggregation and select query, and will this query will be used to insert data to this table. Right.
You can see there's a background query running. In the ksql, they call this some like materials view, right? They don't have a clear concept of materials view. Your phone is too heavy. Okay. Yeah, let's take a look at this topic. I'm not sure if the topic is there should be a ksql, right? If you take a look at those message, yeah, you can see this is the aggregation. It gives you the aggregation result into this table. So that's the ksqlDB. Next, I'm going to talk about a little bit of Materialize. Materialize is a leading streaming database in this area. So you can see the concept is a little bit different compared to the other models. So it has the source and seek, right? So that's very because in previous concept, there's no such concept of source and seek. The Materialize create this. So that means you have a Kafka source. Based on this source, you run some query, create a materials view, and you can query this materials view. And this materials view can link to a sink, which means that sink will write data to a Kafka topic as well. So I'm going to show something about that. Okay, I close the ksql. Make Materialize. So Materialize is actually I'm using the PostgreSQL client because Materialize has a PostgreSQL protocol. So basically, you can use it just like any Postgres servers. So so first one in Materialize, you actually create a source. You can see in the source, I create a broker using from Kafka. The broker is something, and the topic is something. And the start offset is 0 because I want that means I read data from the very first, and the format is bytes. That means I create a source with the raw data. Okay. So now the source has been created. Let me show sources. Yeah, you can see there's a source called carlib data, right? So I can describe that. I don't know. Slow. I don't know, right?
You can do maybe 1 minute for the class.
Yeah. Right. Let me quick run the demo. So next step, I'll create a materials view, doing some data binding, data extractions, and then I can run this tumble window. One thing I want to mention here is actually Materialize doesn't have a tumble concept. You have to manually calculating the timestamp and using this logic timestamp to calculate the window, right? This is like a 10-second window I'm running. So right, and then I create a materials view, and you can show something from this view. Okay, there's no data yet, because there's a time maybe later. Yeah, it's coming. I think not yet.
I think it's interesting that Trino doesn't have that logic timestamp.
Yeah,
Trino is, like, that's interesting.
And I can run. So this is the old version of Materialize. Let's take a look if there's anything aggregate results coming. Maybe it takes some time.
Also back to it's sometimes difficult to map some special field from the SQL you don't really specify, but bind it to the offset that what you can't. So
okay. Yeah, and you can create a sink that connected to this Materialize view. And yeah, and then we can actually run the check the views.
So in this case, the Kafka cluster can be different.
yes, because it's similar to like they don't really own or run the stuff on the content.
Yeah. Yeah,
In the previous material, everything in memory, even though now they have this new version. That's no faster version one time, you have to be using hard version for faster. And the field storage, in that case, you have to get into the both are considered version.
yeah. And one thing to mention is that you remember that the topic we created is Materialize cloud live data aggregation view sync. And when you take a look at topic, actually Materialize append some generated ID. So that's how Materialize works. But you need to know that the topic name is different than your sync name. There's no message yet. Probably still running some background calculation. But anyway, this idea is that using Materialize, you get the data. But the difference is actually Materialize doesn't run streaming query. Materialize is streaming, but when you query data, it's actually still a batch. But you can Materialize support some subscribe tool, or in the previous word I'm using is I call something tail, a similar effect.
This is very kind of in beta of the other compared to the other ones. This is the one that's most in beta. And it's the one that's also most batch. It's streaming, but it's the most batch-like.
Yeah.
Whereas like Flink and ksqlDB are very on one end of the streaming spectrum, like very streaming. This one tries to like feel like batch, but do it in real time.
Yeah, also the slogan that is this new streaming database that you are very familiar with.
Yeah.
It's a trade-off. Everything.
Yeah.
Yeah, next I'm going to show something with Timeplus, but I will skip the rising wave part, because rising wave is very similar, like Materialize, same technology, same concept. So, but I'm going to talk a little bit about Timeplus.
What do you mean by same technology?
Or Rust, and yeah, they're using Rust to build. Later I will talk about that.
Also Rust based, also with Postgres one on.
Yeah.
I think the materials view.
It's not like the other timely data flow guy who's has a competing. Anyway, sorry. Okay.
It's very close.
Yeah, this is how Timeplus model this part. You have solve, stream, very similar concept like a Materialize, but a little bit different when if I show you the demo. In Timeplus, let me log into. Okay, yeah, this is a Timeplus UI. It's we call it console, right? It's Joe's account. So we are now run public beta. That means it's free to use. You're just using your Google account. You can go to use it free. So first, I'm going to create a source, right? So we are not embedding the source into part of SQL, but we provide this UI, so you can basically create different data sources. So this is a Kafka's data. So make it bigger. So I'm going to create this source called Kafka. And I'm going to run this cell. The Kafka broker is Kafka.
Okay, come to this one. It's in your.
Yeah, it's in a cluster, right? So the topic name is car live data, and format is JSON. So.
Oh, because it's in the same cluster.
Yeah. Let me take a look. I think probably the bug. Yeah. Okay. Oh, Kafka is maybe the Kafka is not working. Let me take a look.
No, you can just use the one from.
Should be working, right? Let me take a look. Kafka. Maybe it's the service. Let me take a look. It should be working. Kafka, let me check Kafka. Get top card, live data.
This is your deploy version, right?
Yes, that's right. Yeah.
And how will it connect to 126? You're checking localhost or the Q cluster, is it exposed?
It's running in the same.
It's running the same Kubernetes.
Oh, okay. This is not
see,
deployed.
Yeah, I think it's
Your own VPC.
I think it's on local host.
In our own, we're using EKS, which is Materialize Kubernetes, and our cloud is the same.
Oh, so you are running on that?
Yeah, it should work. But you guys can, you're welcome to try this like Timeplus.com. You can just
let me take a look. Yeah, it should be working. I just switched to my existing source. Let's take a look.
Demo code is not.
Yeah, actually, there's the same one which is running here. I don't know why. Maybe I use a different, but this is the same. Let me try again. Probably this one will on. It should be. It doesn't matter because this service should be available.
It's scary in my opinion.
Yeah.
Pray for the level
Yeah, maybe we skip, but I've already created a source here. You can see here the car demo. It's actually reading the topic from the car live data and insert into the this topic. So in the stream, we can see this car live data from Kafka. I don't know if it's working, but let me take a look. Yeah, it's actually working, but I don't know why the source was broken. But you can see that it's same concept. That source is connected to the topic, and we are actually reading data from the topic. You get all the real-time data here. So similarly, we can run in aggregation. Say max, for example, right? Max speed. As max. Sorry. Or maybe I need to take a phone. Yeah. Yeah.
Should be this one. So for this particular one, we don't set any time window, whatever. So this is called this is called global aggregation. That is, from the moment you start a query to forever, as long as the query is not complete, we always calculate what's the max. So in this case, we do this calculation.
Right.
Yeah, and go on. Yeah.
Yeah, this we call the global aggregation, right? So that means we get the data from the stream and do the aggregation in real time. Every time there's new data, we give you the new result. Of course, we can run the other aggregation like a tumble window. So we just tumble from this car, say, I want to do the 5-second aggregation, group by window start.
And the syntax is similar to other ones, a little bit more easier. So that now you have to write interval.
And
some streaming companies deploy databases like I forget the names, but like some companies say deploy Flink, right? You mentioned that earlier today. Is what you are showing here, is this a streaming engine that you built yourself as like the company has built, or are you deploying one of the other tools that you showed us? Like, is this
yeah,
one of the other tools we already saw?
Right, sure. We build the engine is built by ourselves. We actually build we are different technology. I will mention that later.
Okay.
But we are using C++ to build the engine. It's a little bit different. Of course, we can actually export the results like downstream. We can send data to another Timeplus or send to Slack, email, or any other. We are still, that means we can send data to downstream as well. So in the UI, we can do the settings. So yeah, that's the demo part. So a quick summary here about the different technology we are showing today. So you can see this table, right? So we show you Flink, ksql, Trino, Materialize. Rising Wave I didn't show, but it's basically same as Materialize and Timeplus, right? So all of them most likely stream processing. Trino is batch. Materialize and Rising Wave has streaming processing under the hood, but you can still consume the data like a database, right? You can still run the batch query. Timeplus is similar. We support both batch and streaming, but streaming is mainly what we are building. For consumption, like most of the streaming processing, when you consume data, you actually the server will push the data. You don't have to pull the data. But Trino is batch, so it's full based. The programming language like Flink, ksql, Trino, they're Java based. Materialize Rising Wave is Rust based. And Timeplus is we build it using C++. So that's the under hood engine. So for the stream processing, you for sure get this time window. But some other doesn't, like I mentioned, actually Rising Wave has this time window, but Materialize only you have to calculate the window by yourself. It doesn't have embedded function for time window. For the storage, you can see Flink doesn't have storage. It's a pure stream processing engine, so it doesn't store data by itself. But there's a community plan to support table engine that they're doing that, right? ksql using Kafka as storage, so it stores everything in Kafka internally, right? Of course, they have their checkpoint or using RocksDB. Trino is an in-memory engine, so Trino doesn't store data as well. Materialize has its cloud, Rising Wave has this cloud local storage, but they're moving very fast. Previously, Materialize is also a pure in-memory engine, but they're building their storage now. Timeplus has a cloud storage and local storage as well. Actually, Timeplus has a historical engine. That means we can actually run as a batch or lab database in the batch mode. So Timeplus is actually dual mode for both streaming processing and like a batch processing and all lab. And the license is quite different. Like Flink is the open source Apache. ksql is the CCL. Their own Confluent community license. Trino is Apache, and Rising Wave is Apache. The Materialize is BSL. So that means these two licenses, like a ksqlDB and Materialize DB, is not a pure open source because their license is not user friendly. Because Timeplus we are pretty new. We're still building everything, but we do have a plan to open source our core, but we are at very early stage. We think even the open source our code now, probably nobody will be using it. So we probably will wait a good timing to open source our core. So, but now if you want to try Timeplus, it's free to use because we are running public beta. Okay. So, okay, this is the data architecture. This is from the K60Z. There's a big data landscape. So, but there's something related to the streaming data, right? Like even streaming, you have Kafka, Kinesis, Pulsar. And for the real-time analytic, you have previously you have ClickHouse, Pinode, or Rockset, right? And also the stream processing engine like Databricks means I think probably that's the Spark, right? Confluence has ksql Link and some Materialize DB, right? This is stream processing. So and Timeplus we actually here by real-time analytics. Right? So that's something we are building now. Yeah, this is the overall architecture, high level stuff of what Timeplus is doing. So we have connectors to the upstreams, we have connectors to the downstreams. We have an internal storage for the streaming data and the historical data. So we build our own data format so that, like I mentioned, if you want to analysis data on streaming on Kafka, it's not easy because it's an up and down log. It's not a you cannot build index. You cannot skip something. You cannot filter out a column like a column database. So that's hard. So that's why we build our own data format, and we work closely streaming first store, and also we have a historical store, so you can run query smoothly between streaming mode and also the historical mode. So we have our own SQL engine. We have a streaming processing engine. So we leverage vectorized computing to boost the query performance. Also, you can see that we actually has an all-in-one platform. So we have real-time dashboard. We have alert function built in, right? So that means I didn't show that today, but we do provide visualizations. That means we have real-time chart and real-time dashboard. So that means we are not just a SQL engine. We actually it's an analytic platform. You can do the and streaming analytics on Timeplus. So this is some showcase we have building. We do have a showcase where we analysis the GitHub data, right? I'm not going to talk about those, but we do have built some fleet management solutions, because one of our customers is running a large number of fleet, the trucks, right? So the security is their concern, and this real-time security. So once there's some truck is over speed, or the driver is driving too much without rest, so we can send an alert, say, oh, there's some car is over speed, or some driver didn't have rest in the past time. So we notify them in real time. So they think this some solution they really love. So this is something built using Timeplus technologies. Okay, so yeah, that's probably Joe. You want to make some wrap up?
Guys, so we can leave more time for the Q&A session. But just to wrap up, that is, I hope you learned something. That's already this entire session can be long, but the idea that is, compared to 5 years ago, the customer really have a much higher expectation to see what's happening right now. As enterprise, you want to get to the report earlier, you want to take real-time actions. Ideally, even no human being in action, everything can automated, that'll be great. And you don't want to spend too much time reinvent the wheel, manage infra. So we do have a much better choices compared to 5 years ago, like the rising of streaming or streaming database. And there's a lot of new semantics or best practice being invented. And we are glad to work with the vendors to make this easier for you. And there's so many different use cases, the customer 360 or the fintech. There are so many use cases, no matter external or internally. So I'm glad you guys joined the session. Hopefully you can try to understand what's going on in your Kafka, maybe using SQL, maybe using Timeplus, maybe use other tools, but try to do more with your real-time data. And that's something that will be very interesting ahead. Yeah. So maybe with that, we can take questions or
any
doing freestyle check. Yeah.